So hi everyone, myself Rekha, Assistant Professor, Department of Mathematics. So I am going to explain the F test for the problem and solution in the test of hypothesis small sample test. So this comes under the course Discrete Mathematics with Probability and Hypothesis Testing. So before going to the F test, I am going to explain what is the F test. So F test is nothing but we have to calculate, there are the three tests, I square test, T test, F test, and the F test formula is F is equal to S1 square by S2 square. That is nothing but then large sample, that is sample 1 and sample 2 square. For example, if we want to find the F test, means we have to compare the two population. There is several populations are there, and the uses of the F test is before going to that, the equality of the two population variance has to be calculated, and assumption of the equal variance before testing the t-test, and analysis the variance using the ANOVA table by using the several population means are equal. So based on that, this is very simple test compared to the previous chi-square and t-test. And what is the degree of freedom in the F test is nothing but F test, so that is the two degree of freedom. One is the numerator of degree and denominator degree of freedom. So numerator degree can be calculated by V1 equal to N1 minus N2. Denominator degree is N2 minus N1. V1 is nothing but numerator and V2 is denominator, and N1 is the sample size 1, M2 is the sample size 2. And therefore F test is denoted by F of V1, V2. These are the two degrees of freedom. And hypothesis is nothing but we have to fix the two hypotheses. One is null hypothesis, another one is alternate hypothesis. Null hypothesis is nothing but h0 sigma 1 square equal to sigma 2 square, whereas the alternate hypothesis is nothing but sigma h1 equal to sigma 1 is not equal to h2 square. And the F test is nothing but large sample variance and small sample variance. And the two laboratory measures the concentration of the chemical in the same solutions of the each lab. Sample size N1 equal to 15, sample variance S1 square equal to 36, N2 equal to 13, and sample variance S2 is equal to 16. So how to calculate the F1 test is nothing but we have S1 square by S2 square, 36 by 16. So if we calculate it, means we will get a 3.206, but we have considered the alpha as 5% level. So 5% level means we have to conclude whether we can accept the hypothesis or reject the hypothesis. Already we have fixed the null hypothesis of two population variance are equal and two population variance are not equal. So F is equal to S1 square by S2 square. So 36 will be greater than 16 if alpha is equal to 5% significant level means. So we have concluded that 5% level means there is not significant difference between the variance of the two laboratory. So the population variance of the lab X and lab Y can be considered as equal compared to the all the values. Next, another problem we can say that another problem we can conclude that a company wants to check a two machine product item with an sample variant. Two sample sizes N1 is equal to 100 and 10. Sample variance S1 is equal to 25 and sample size N2 is equal to 12. Sample variance S2 square equal to 10. So F is equal to 0.05, 9.11 is equal to 4.0. By calculating the sample variance, you already know the F test formula, large sample size by the small sample size. So H0 is sigma 1 square, sigma equal to sigma 2 square, and x1 equal to sigma. So this is a two-tailed test, and if you calculated the value, you will get 25 by 10, you will get 2.5. But the real sample is greater than 10. So degrees of freedom also we have to calculate N1 minus N2, N2 minus N1. 10 minus 1 equal to 9, 2 minus 1 is equal to 0. So we can conclude that it is an 11% value, and 4.06 means 2.1, and it is nothing but 4.03. We accept the H0. So conclude that there is no significant difference between the population variance. So machine A and machine B obtains an same accurate value position between the values. So based on that chi-square test and F test, we can conclude that it is a good alternate hypothesis, and compared to that we will conclude that it is an best one compared to F test also. So based on this problem we can use all the variants. So thank you for watching this video.